This lecture I want to talk about multidimensional arrays. Up until this point, if you've thought of an array, you just said an array is a variable that can store many types of data. It can get more complicated than that. You can have basically many dimensions of an array. So if you just have a linear array, which is what we've discussed so far, that's called a single dimension. And we know it's a single dimension because it just has one brackets with one size. The C language allows arrays of any dimension to be defined. So this is kind of thought of like a nested array, an array of an array. So two-dimensional arrays are the most common, but you can actually do three-dimensional arrays, four-dimensional arrays, five-dimensional arrays. But there's not many use cases for 3, 4, and 5. Really, you're either going to have a single-dimensional array that you use in your program or a two-dimensional array. Two-dimensional arrays are common because they essentially represent, for example, like rows and columns in a spreadsheet. That's how you can kind of visualize it. Or a matrix, or a table. That's a two-dimensional array. You have rows and you have columns. So you can store more data than a single-dimensional array by specifying the sizes. But it's very applicable because it looks like a matrix. And there are applications that you may want to write that has this concept of a matrix. Specifically, a mathematical application would be most relevant here. But you can use to do two-dimensional arrays for many different things. One example is a matrix. But again, visualize it as a table. Two-dimensional arrays are declared the same way that a one-dimensional array is. The only difference is you now have another set of brackets. So in this example, we're declaring an array named matrix of type int, which has 4 rows and 5 columns. That means you can store 20 elements inside that two-dimensional array. So you should know how each dimension is specified with its own pair of square brackets. That's how you can easily spot how many dimensions an array has. If you had 3 brackets there, that would be a 3-dimensional array. If you had 4, it'd be 4. This one has 2, so it's 2. And up until the earlier lectures, we only had 1, so we knew that was a single dimension. All right, so look at the brackets. Pay attention to that. Again, 4 rows, 5 columns, total of 20 elements. To initialize a two-dimensional array, it's going to be initialized in the same manner of a one-dimensional array. Same type of syntax, you're just going to add more. So when you list the elements for initialization, the values are going to be listed by row. And the difference here is that when you put the initial values for each row in, you're going to do it between braces, curly brackets. And then you're going to enclose all the rows between braces. So it's going to look something like this. If we create an array of numbers, which is of 2 dimensions, 3 rows and 4 columns, and we want to initialize it, all you have to do is put inside curly brackets the entire array, and then add inner nested curly brackets for each row. So here, we're initializing values 0 sub 0 to 10, 0 sub 1 to 20, 0 sub 2 to 30, and 0 sub 3 to 40. And that's how you access multidimensional arrays too. You access them with the row and the column. You just have to remember that it's 0 based. So the upper left hand coordinate there, the upper left hand, which would be row 1, column 1, would be 0, 0, and that'd be equal to 10. Row 1, column 1, column 2, I'm sorry, would be equal to 20. But you would access it as numbers 0 sub 1. So the first element, because the first array contains 3 rows, that when you access it, that's the number you specify for the row number. And then the column number is the next specification for accessing the array. But initialization is pretty simple. Just separating things by commons with the brackets. And accessing them, you would access it just like you access a normal array, except now you're accessing this concept of a row and a column. So the use of the inner pairs of braces is actually optional, but you should use it for readability. If you didn't provide those braces, you could actually just provide 10, 20, 30, 40, 15, 25, 35, all just consecutively. But it's very hard to visualize what you're initializing. As a programmer, readability is very, very important because it increases the quality of the code. It's easier to maintain the code. When I look at this right here, I can easily identify, especially with the comments, what I'm initializing to. What values and what rows are getting initialized to. If I had that as a single line, just consecutive numbers, I would get lost really quick. So although the inner brackets are not necessary, use them. As with a one-dimensional array, it's not required to have the entire array be initialized. You can just initialize certain areas. So in this example, we're creating an array, two-dimensional array, with 4 rows and 5 columns. We're only initializing the first 3 elements of each row. So row 1, column 1 is 10, row 2, column 2 is 5. I'm sorry, row 1, column 2 is 5, and row 1, column 3 is a negative 3. And the same for the second column and so forth, 9, 0, 0, 32, 21, 0, 0, 8. For the ones that we didn't set, the 4th and 5th values of each row, those are actually going to be set to 0 automatically because we left them out. And in this case, you actually have to provide the curly braces, the inner ones. Because here, if we didn't, the initialization would be all screwed up. Because if you didn't have the curly braces, it would just do it consecutively. So what would happen is, this would actually initialize the first 12 elements. So it would initialize all the elements in the first row, all the elements in the second row, and then the first 2 elements in the third row, and then the rest of the elements in the third row, the rest of the elements in the fourth row would be 0. Again, this is a two-dimensional array of 4 rows and 5 columns. It would just do them consecutively. So don't forget the braces if you only want to specify certain initialization elements. You can also do designated initializers. Remember, this is the C99 concept. That's optional in C11, where you can specify specific indices to be initialized. So you can use subscripts in the initialization list, just like in a single dimensional array. If you want to do a designated initializer, you would just do something like this. So here we're declaring our matrix array of 4 rows and 3 columns, but we're actually specifying that 0, 0 is equal to 1, 1, 1 is equal to 5, and 2, 2 equals to 9. So when we say 2, 2 again, what we're saying is row 2, which is really row 3 because we start at 0, column 2, which is really column 3. Again, visualize this as a table or a spreadsheet, and accessing the elements start at the top left-hand corner. But if you understand that the 4 represents the rows and the 3 represents the columns, it's pretty intuitive after that. So what this is doing is it's initializing the 3 indicated elements of the matrix to specified values. But what you should notice here is the syntax. All the unspecified values here are going to be 0 by default. So this is only going to initialize 3 values. Each set of the values that you do initialize are going to be the elements in a row is between braces. And then the entire initialization goes between another pair of braces. So you see that we have the curly brackets on the outer ones, just like normal initialization. And then we have the brackets to access the array inside. And then we have commas to separate each row. And each set of row values is separated from the next set by a comma. So the values are separated and also the row indices. So notice that. Now, just because we said that we have 2 dimensions and we've been talking about that, you can actually have many other dimensions. Everything I've talked about with 2 dimensions also applies to 3 dimensions, 4 dimensions, 5 dimensions. So if you wanted to declare a 3-dimensional array, you would do it with 3 square brackets. So here's an array named box of type int of 10, 20, and 30. You might want to use a 3-dimensional array maybe if you were, I don't know, maybe if you were storing XYZ values of some sort. You probably won't need to do this. 3-dimensional arrays and up are really not common. But you can visualize a 1-dimensional array as a summary. You can visualize a 1-dimensional array as a row of data, single row. 2-dimensional array as a table, a matrix, or a spreadsheet. And a 3-dimensional array you can visualize as a stack of data tables. So a stack of tables. If you needed that much data, it's going to be really hard to access it and probably confusing. And anybody that's maintaining this program for a 3-dimensional array or above is probably going to get lost trying to figure out what's going on. But you can do it. Again, and if you're ever going to need to iterate through any of these 1, 2, 3-dimensional arrays, you're probably going to use a loop. And the more dimensions you have in the loop, the more nested loops you're going to have. So if you want to process a 3-dimensional array, you're going to have 3 nested loops. And if you want to process a 4-dimensional array, you're going to have 4 nested loops. So as far as initializing an array that's higher than 2 dimensions, again, you're going to apply the same type of thing. You're just going to extend it a bit. So a 3-dimensional array will have 3 levels of nested braces, with the inner level containing a set of initializing values for each row. So it would look like something like this. Here we have a 3-dimensional array, 2, 3, and 4, a stack of data tables essentially. And the first block of 3 rows we're going to initialize, and the second block of 3 rows we're going to initialize. So what this is saying is, again, first block and second block, because we didn't initialize the third and the fourth block, just the first and the second. So we have 4 blocks, and you can think of as each block a stack of data tables, each block having rows and columns. So the first block is going to be initializing just the first 3 rows, which is all we have is 3 rows. And then the second block is going to initialize the next 3 rows. But the third and the fourth blocks are not going to be initialized. If you wanted to initialize the third and the fourth blocks, you'd have more inner bracey, curly brackets, and so forth. Same thing applies though for the ones that you do not initialize. They will be initialized to 0. But again, you can see how it gets very tedious and also very hard to follow. When you want to process the elements in a dimensional array, I mentioned you're going to use nested loops. Again, it's going to correspond directly to the number of dimensions. And each loop is going to iterate over 1 array dimension. So it's going to look something like this. This is an example of a 3-dimensional array. You have an outer loop, and then you have 2 inner loops. The outer loop is going to be the first outer array, and then the second one will, so the outer loop would essentially go through the rows. The second one will go through the columns, and the third one will go through the blocks.